Good. I am super excited to be here. I've been here, like they said, to a number of securities. I've had so much fun. The honorary member thing is like, holy cow, this is my first honorary anything, except for some of the bad words they say down the pub. And I thought, gosh, they've asked me to keynote. I mean, you got to have balls to keynote a security. So I brought balls. Little hacky sacks. Hope you guys are awake. Heads up. Heads up, here they come, look up. There you go. I got a bunch of these, and I want everybody to be awake because we're going to do fun stuff. And I'm not going to throw an entire bag of them, right? Oh, you need one. Hey, I got hands up, hands up. There you go. All right, so we got that out of the way. Good morning. My name is Paco Hope, and I work at AWS, right? So the cloud. So it's one of the many things Amazon does. It's a lot of fun working at Amazon. And I used to work at Cigital, which then became Synopsys, and you'll see a bunch of the Synopsys folks around. I'm really happy to see them continuing to support. I work in a division called Professional Services, right? So it's consultancy, like you might expect, and I help customers who are going to the cloud. So they'll have, things like, we're trying to move 2,000 servers out of this data center into the cloud before the lease ends in October. Go. And then I worry about the security side of that. Is the data encrypted at rest? Is it encrypted in transit? What are the access permissions? All that kind of stuff. So I help customers do that. And I'm going to talk to you about incident response and forensics in your pajamas. This is what I wear to work, right? This is my work outfit, and I want to show you that even if you're dressed like this, you can still do incident response and forensics. Before I get into that, though, I think for some people, I do need to define kind of the cloud. I was at drinks last night, and I actually had someone ask me, what is AWS? And it's one of those sort of record scratch moments, like, somebody actually hasn't heard of us. That's okay. That was a surprise. So cloud computing, if you're used to having like servers in a data center somewhere, right? You've got this big room, and it's got network and power and cooling and all that good stuff. The cloud is when instead of owning all that kit and running it yourself, you're renting time from someone else who does it. So AWS runs the physical data centers with the power, the cooling, the network, the people, the CCTV, all of the physical security. And so our definition for cloud computing then is when you have on-demand IT resources, right? So if you buy that server and you stick it in your server room, you've paid, you're done. Even if you never turn it on, you pay full price, right? If you never use it, you've paid for it anyways. Where in the cloud, we have this pay-as-you-go pricing. They're literally like light bulbs. When it's running, you're paying. When it's not running, you're not paying, which is a totally different model. And it actually shifts, as companies change how they do technology, instead of this capital expenditure, this big massive outlay, like every 3 years, hardware refresh, 4 million pounds, bam. Instead, it turns into this we're renting time on computers, and so we're using X number of instances per hour, and that becomes hourly and monthly charges, and it becomes operational expenditure. I heard from a big customer in the oil and gas business, and he's like, suddenly accounts payable became part of our critical path. Because if they don't pay the bill each month, bad things are going to happen. So it's actually a really different outlook. So that's the cloud. Right, when you're renting computers, when you're using the services, but you don't have to physically own the hardware. And if I'm going to tell you what is the cloud, well, I should probably tell you, what are pajamas, right? We're going to talk about the cloud. We're going to talk about pajamas today. And pajamas is loose-fitting, comfortable clothing, totally suitable for people who work from home. I don't know if any of you have done this yet. I have done the thing where it's like I've got my pajama bottoms on and I have a button-down shirt because I'm doing a video conference. I have done that, and it totally works. So yeah, pajamas are fun. They're comfortable. It's great when you work from home. But if you had to go to a data center, well, you can't go there like this. Heck, I'm lucky that health and safety didn't stop me, getting this far. But they sure as heck aren't going to let you in a data center dressed like this, and you wouldn't want to. So I want to tell you about incident response in the cloud, but I think we have to cover some ground rules first, just some basic understanding. I actually had this question asked to me this morning. It's like, well, if you guys own all the servers and all the physical stuff, who's in charge of security? Well, that's a great question. Right, so we have this whole concept we call the shared security model, shared responsibility model, rather. And basically on here there are 3 sets of responsibilities. There's stuff that we do and you don't. There's stuff that you do and we don't. And then there's a bunch of stuff in the middle where it's kind of your responsibility, but you're going to do it with tools that we made and we make and tell you how to use. So all this bit at the bottom, you can see this little dotted line through the middle, right? All the stuff at the bottom, the compute, storage, network, all the physicality of things, those data centers, that's our responsibility. And so the security, the employment, any of the things you think of traditional security, all the ISO 27001 stuff related to the physical infrastructure, that's our responsibility. That's the AWS bit. At the very, very top, you have the kind of customer data. You put some records in the cloud. They're in a database, they're in S3 objects, they're on a server instance, it's your code in a code repository, whatever it is. You're responsible for your stuff. And then in the middle, you have all these things like, what operating system is that instance running? Is it an up-to-date version of Linux, or is there something vulnerable? Is that an up-to-date version of PHP, Python, struts, Java, Oracle, whatever? Or is it a vulnerable version? Those are customer responsibilities. That's kind of your job. And then there's some stuff there that like network security. What IP address can talk to what other IP address? So, the routes and the virtual private cloud VPC, the subnetting, the security groups, which are like instance firewalls and network ACLs, all that is customer responsibility. They do those bits. But they do it using tools that we made, right? Interesting thing, because you're going to see a bunch of talks today, and there will probably be some network security things, I do like to make this one interesting remark about the network layer in the cloud. There's no layer 2. Layer 2 doesn't happen in the cloud. So think of all the things that are layer 2 type attacks, DNS spoofing, ARP spoofing, cache poisoning, all these kinds of things that involve somehow like ARPing on the network or confusing a nearby neighbor. Doesn't happen, doesn't exist. So it's like if you had .4 and .5 on the same subnet in your data center, what kind of connectivity do they have to each other? Probably a lot, right? They're probably jacked into the same switch. And in the cloud, if you had 2 instances on the same subnet, .4 and .5, how much connectivity do they have? Not a bit, unless you go create a security group. These two literally have adjacent IP addresses and can't send a single packet to one another unless you go create some connectivity. So it's worth sort of thinking about. It's also worth noting that this is one shared responsibility model and there are others. Not just because there are other clouds, but even within AWS, if you use S3, like we're storing stuff for you, right? And there's an HTTP interface to that stuff. What servers is it on? How many of them are there? What version of Linux are they running, or PHP, or whatever it is behind it? Don't know. Not your responsibility, that's our responsibility. But the data that's in S3 is your responsibility. So that just sort of gives you this idea. So this is important as we start to get into the security, because you have different responsibilities than we do, and I'm going to focus on your bits for the most part. Now, when we think about securing stuff, we think about a couple of different kinds of security controls. We break it into 4, and these should look familiar, even if it's not exactly the same words you use. So directive security controls are, we only use the London region, or we only use Dublin, or only these people have administrative access to this infrastructure. Those are your directive controls. You're kind of laying out the framework and what's going to happen. Preventative controls are stuff like, packets from this IP address, drop them. Requests that don't look this way, decline them. They're the things that stop bad things from happening. And a lot of your on-premises security will lean really heavy on the preventative control. Give me lots of firewalls, give me IDS, IPS, give me lots of things to block the bad stuff, stop bad stuff from happening. Now in the cloud, you really have to actively manage it. You have to be participating in it. You don't just kind of set the thing up and leave it running and trust that it's going to be all right. You actively monitor and manage it, which is why detective and responsive things are so important. So detective controls all the logging and all that nonsense about who did what and when. And all the responsive controls are like, whoa, we detected a bad thing happening. Let's go do something about it. And if we're talking about incident response, then we're really going to be down here, right? We're going to be down in this sort of detective responsive world today. We're going to really be focused on these guys. And we're not going to say a whole lot about the directive and preventative bits. So if you're in the cloud, what kinds of stuff might you have to run into? And this is a really interesting incident conversation because there are some incidents that are common, just the same kinds of things you're going to run into in any other situation. And some of these will be uniquely cloud. And I'm going to do them from kind of least big deal to biggest deal, right? Compliance variance is a pretty basic, like, we've decided all our instances will have encrypted hard drives. Somebody just started up an instance, its hard drive is not encrypted. Like, we may not have actually done anything bad yet, right? It's just we intend to have everything encrypted. Maybe they've just brought it up and they haven't even loaded data on it yet. So there's not actually any real huge risk, but it's compliance variance. We should fix that. Those of you taking pictures, this thing's going to build. I got 8 of these, so I wouldn't don't waste the film yet. Service disruption is, we intended a server to be up, we intended this data to be accessible, we intended this database to answer queries. It's not. These are incidents that we might have to detect. And service disruption can be, often it's a performance thing, and the operations team is looking at, gosh, the performance is not so good over there. And that might actually be an indicator of compromise. Like, sometimes the performance alert is the thing that tells you a hacker's doing something. I'm part of a team called Zipline, which is kind of, we actually had to change the name, but we still call ourselves Zipline. And what that is, professional services consultants who can kind of go in and rescue customers when they have a really, really bad day. And, you can put me under contract, and then I'm allowed to do whatever any contractor working for you is allowed to do. Whatever you authorize me to do, we have legal right to go do that. And so it is kind of like, we're here to help. And one of our Zipline cases, we had a customer who had database and really high load on their database instance. And it's RDS, Relational Database Service. So it's one of our somewhat managed services. And so they call up our support and they're asking questions. Why is the database load so high? And we'll resolve. Look at, well, what about this auditing plugin? Do you need that auditing plugin turned on? Have you looked at your query performance? Maybe there's something, somebody pushed a new update to your app and it's inefficient. And on like the 4th day, they get a ransom note. Like, we have all your data, and we're going to release it publicly unless you give us some money, right? And so that high CPU load on the database server, that was all their data going out. That was a bad guy had gotten the username and password for the database, and it sucked a whole lot of data out. So sometimes, it's an incident because it's a service disruption or performance issue, but sometimes that's an indicator of compromise. There we go. Just got to flick it a little bit. So, unauthorized resources. This is a thing that doesn't typically happen in your data center. I don't know how many of you guys have come into the data center and there's 4 new servers in there. Where'd they come from? Most big enterprises who run data centers run them with a little better security than that. So you don't generally have stuff just spring up in your data center. But in the cloud, this can really happen. Right? In the cloud, you generally let people spin up servers and let them spin up buckets and instances of things so that they can learn and develop and do whatever. But sometimes they can do it wrong, or someone gets a hold of credentials and they spin up things that they shouldn't. So unauthorized resources is something that happens in the cloud fairly often, and you need to respond to it. Unauthorized access, and this can happen in a couple of flavors, right? Unauthorized access is somebody's got access to my environment. Maybe they've got my laptop, or they figured out how to do AWS commands, and they're actually looking around or making changes to things. Or maybe it's like SSH, login access to one of our servers, one of our instances in the cloud, and maybe they're actually inside it messing around. So now we're starting to get into some things that are fairly serious, but also things that you're familiar with, things that you've dealt with before, certainly inside your instance. Inside of Linux, inside of Windows, privilege escalation or unauthorized access, you're used to dealing with that. Privilege escalation, again, takes 2 flavors. There's a privilege escalation inside of Linux on some server or some instance somewhere. Or is it privilege escalation within the cloud itself, granting someone ability to create new cloud resources or change the ones that are out there? So two flavors of privilege escalation. Or excessive permissions. I call this the Steve problem, because I was doing a talk like this at a customer, and they had already been moaning a whole lot about Steve, who apparently had lots of privileges in their cloud environment. And when I put up the thing about excessive permissions, everyone just kind of looked over at Steve. I was like, okay, so this is the Steve problem, right? When Steve's that guy who's got all the privileges, got all the passwords, got all the access, that can be an incident that we have to deal with. Information exposure you see on the front page, right? This is the S3 bucket that's open to the world. This is the functions that allow you to get location data out of cell phones without any authentication or authorization. This kind of information exposure is a high priority incident. And then the granddaddy of all of them, credential exposure. When you commit credentials to GitHub, your AWS access key and stuff, it's a race between three parties to see who gets it first. Is it the developer who did it and says, oh shit, and has to go try and delete it? Is it AWS, because we actively patrol looking for stuff like that? Or is it the hacker who finds your access keys and says, ooh, let's see what these can do? So these are the kinds of incidents in the cloud that we might have to respond to, and they largely fall into a couple of domains. If we had to group them all up, we would say you've got your infrastructure domain, which is stuff that feels familiar, right? This is the kind of like servers, EC2 instances are these kind of virtual servers in the sky. And, connectivity, your networking, your VPN, your networking within the cloud or between the cloud and your data centers. And anything inside the instance itself. Somebody has gotten into a Linux box and they're messing around and we want to know what happened. These are your infrastructure events. And there's a few others, but this should sound familiar. But there's this whole second class of things, which I call the service domain, where everything you're dealing with is an AWS service natively. So AWS Identity and Access Management. You have an AWS account. It has roles and privileges and rights and capabilities. And if there's a problem, there's no server to go yank. There's no box to go image. It's up in the service layer, and you have to use AWS APIs and AWS logs to figure out what happened and what's going on. S3 buckets, they're a very common thing. Like, people store a lot of stuff in there. I was talking over dinner with somebody who had moved, 670 petabytes? Yeah. Was it 670 terabytes, I think. At any rate, a bunch of data. And, so S3 buckets, if that data gets exposed, it's going to be highly available, it's going to be highly downloadable. And there, again, no server to yank. The question is, do you have S3 access logs turned on? Do you have CloudTrail, which figures out who was messing with stuff and who was calling APIs? Do you have that turned on? Billing. It's surprising how much billing turns into an indicator of compromise. Remember how I explained you pay by the hour, or you pay by the gigabyte for data over the network, or you pay by the gigabyte for storage? So spikes in billing either mean a project has just kicked off in high gear, or somebody's doing something really weird and you should go investigate. And we had a customer who, that was how they discovered that they had 20 instances Bitcoin mining in Singapore, and 20 Bitcoin mining in Tokyo, and 20 Bitcoin mining in Brazil, and 20 in Canada. And it was, someone had gotten a hold of some credentials and had spun up a bunch of Bitcoin mining instances. And, they found it by getting a billing alert. Like, wow, you don't usually spend this much money. And billing is a really interesting indicator of compromise. And then the reverse of that was the team that called us up one time. They're like, oh my God, we're under attack, AWS support, help. And we start looking and we're like, all this traffic looks completely legit. We're not seeing DNS backscatter attacks. We're not seeing any of these sort of things that you usually associate with a DDoS attack. And it turns out they'd run a Super Bowl ad. And nobody had told the tech team at all, right? So they had just never seen this level of legitimate traffic. And then, of course, we have lots and lots of other services. And so each of those will be an important thing that you might have an incident in. And then there's a couple of things that are really important, like where do you get the information to respond to incidents in your cloud? And there's a bunch of really important places you can get information. And the obvious one would be sort of logging and monitoring. There's a zillion ways to log and monitor data. Having said that, with GDPR coming into effect quite soon, companies are now starting to question, well, what the hell is in those logs anyways? And do we need to be deleting some of these logs? And what should we be doing about them? So logging and monitoring is simultaneously an asset. It's going to help you figure out what happened. And it's a liability. You need to only keep the stuff you really need to keep. And I just worked with a government agency last week who had done this amazing serverless app in AWS, totally native services and everything. And they had turned on full request response auditing and logging, mainly for like debugging and troubleshooting. And they had just no data retention policy or deletion of anything. They had 2 years of like every request this thing's ever done, and do like 14 million a day. And so like, A, you're a waste of money, man. You're storing stuff that you have zero interest in storing. And B, from a liability perspective, you shouldn't keep it. Let's go figure out what the data retention policy is, and let's go set up a regular thing that just deletes stuff. You might have billing. So billing activity can also tell you what's normal, and you can actually get super deep because everything in AWS is an API. Even the billing is an API. You can go, hey, give me all the breakdown of costs from last month, last week, whatever. Threat intelligence. So there's a bunch of companies out there that sell threat intelligence. Like they will give you threat intel feeds, like here's a botnet, these IPs are suspicious, this domain is phishing, and that kind of thing. You should have that in any sort of organization that you run, in any kind of enterprise, and you can actually feed that into some of the tools that we have in the cloud, which I'll talk about in a second. AWS outreach is a super important source of information, meaning that we can sometimes see things you can't see, and so we might actually pick up the phone to call. And so super important if you're a cloud company, cloud organization, or just an individual playing around who might make a mistake, make sure the records that AWS has on file are accurate, that that the phone number that's on file actually rings a person who would know what to do if we call, that the email address goes to someone who actually understands how to deal with it. We had remember the GitHub example I talk about, where you commit some credentials to GitHub? We had that happen. A customer committed some GitHub credentials. And 5 or 6 minutes after the guy did it, he's like, oh crap, and he deleted them from GitHub. But before that, we had detected it. And we were on the phone and we were sending email. And the phone number didn't work, didn't go to anybody, it just rang. And the email went to accounts payable, because most of the kind of interesting things generally just goes off to accounts payable because it's probably billing related. And they kind of took a look at this like, credential compromise, Bitcoin mining, and they eventually kicked it over to the tech team. So 27 hours after it was detected, then the tech team's kind of made aware of it and they can go clean things up. So make sure that if AWS has to reach in and say, hey, there's a bad thing happening, that it points to somebody useful. I actually found a customer who, they told me that their sysadmin had left 2 months, 3 months before, still had his credit card down and his email address. I'm like, this guy doesn't even work for you. What are you calling him? Hey, Joe, do you mind just paying the bill this month? I swear, we'll get it changed over soon. And then finally, a super important thing that I've learned since I've been at AWS, but I always believed in being friendly as a security person. A friendly security front door is super, super important. If you're the security team and you want to know about incidents, you have to accept information from people that you don't know, from people who may not know exactly what they're talking about because they've just seen something funny. You have to have a friendly security front door. And I'll tell you about the security front door within AWS. Right? We run the cloud, so we have massive security operations. And they literally go around to all the staff everywhere and they say, we have ticketing, right? So we have tickets for incidents. You have severity 1, 2, 3, 4, 5, whatever. Severity 1, CEO gets a phone call. Severity 2, vice presidents are like, what the hell is that, and who's fixing it, and when's it going to be done, and so on. And severity 5 is like, hey, gee whiz, guys, it sure would be nice if you do this. So our security folks go around telling everyone, look, if you're not sure if this is a Sev2 security incident, it's a Sev2. File it. File the Sev2 ticket. If it's not severity 2, we're going to look at it and say, oh, yeah, Sev4, we know what's going on here. We'll downgrade it. That's fine. We want to know. We want to get that ticket. We want to get that alert. We will never tell you, oh, you idiot, you wasted my time. That was no way a Sev2. They're never going to say, you were dumb, you shouldn't have done that. They're always going to say, hey, thanks for that. Looks like the team is on it. We know what's going on. We're tracking it. Thank you very much. So friendly front door, take things from employees, take things from, security researchers and external people you don't know, take things from the development team themselves. Always have a friendly security front door. So given all of that, we might actually, we also have cloud native sources. There's a bunch of stuff that in the cloud you have these things and on premises you don't. CloudWatch events, for instance, can actually respond to a thing has happened. I've noticed this instance is not responding to HTTP requests. You know what? Kill it. Get another one in there. Like you can make your infrastructure run itself by automating through things like CloudWatch events. You can have things like guard duty, which will detect really interesting things happening inside your cloud and let you know about them. If somebody spins up an instance and starts port scanning, guard duty can tell you, hey, by the way, that instance over there is port scanning. And if you want to get really draconian, you could say, great, terminate. Kill it. That is not a legitimate business use case here. Or another fun one that I like, if someone's accessing your infrastructure, they're coming to AWS, not coming to you, they're not SSHing to your instance. They're talking to an AWS endpoint, something we run. Maybe it's something we run in Tokyo. But they've got credentials for you, for your account. And they're coming from a Tor exit node. Right? So this is someone who has legitimate access but is hiding their origin. They're trying to hide where they're coming from on the net. There is no legitimate business use case for this. Right? No business that does anything with me has a reason for its administrators to do legitimate activity hiding where they come from. So for most people, that results in an alert. And we put it on their dashboard. We're like, people are using your account over Tor. That sounds weird. Or again, Bitcoin mining. If your VPC starts talking outbound to some Bitcoin mining sites, again, not a lot of legitimate business use cases for that, so we'll flag it up as an alert in guard duty. Lots of fun stuff like that. So let's do some fun things. Let's actually think about how we respond to an incident. So let's imagine we've got, and I'm going to start with the infrastructure domain. Let's imagine we've got, this is a classic architecture diagram of your really basic web app, right? And there's a few bits that are missing. But you've got your internet, you've got this load balancer, and load balancers are like appliances. They're just a thing that exists. It's not like a server. You can't SSH into it. It's just an appliance. And it's got 3 web servers behind it in a web security group. Security group meaning a network firewall rule that lets web traffic come in. And one of these guys goes bad. Now, I'm not even going to talk about, like, what is it? I mean, maybe somebody's SSH'd in, maybe somebody, something's going wrong, it's issuing bad outbound requests, and we think it's probably been compromised. I don't know what it is, but we don't like it. We don't trust it anymore. We want to isolate this and let's do some forensics on this guy. So, first thing we can do is figure out who he is. And using command lines, I'm going to put a whole bunch of command lines down here, right? AWS EC2 describe instance, the guy that's got this IP address. Who is that? And, you end up with some instance ID, I blah, 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 blah. And so then we say, you know what? Let's put a tag on that guy. Environment, value, quarantine, reference ID. We're basically saying, we're starting an incident now. We're going to quarantine this guy. And so for starters, we just put a little symbolic tag. We're sort of tagging things related to this incident. Now now that we know he's bad, he's still out there. He's still serving web traffic. We don't want him to talk to customers anymore because we've decided he's bad. So we take him out of the auto-scaling group. So he's not the auto-scaling group knows this guy's not part of the team anymore. And again, just a couple of commands, detach it, deregister it. We don't want him in the auto-scaling group, and we don't want him part of that load balancer anymore because we don't want him dealing with customer traffic. Now, the beauty of auto-scaling groups, of course, what does an auto-scaling group say? Hey, I'm supposed to have 3, and I don't have 3 anymore. Let me go launch a clean instance so I get back up to 3. So implicit to this, I'm not even drawing it on the screen, implicit to this, you wanted to have 3, and you took one out because you didn't trust it. A third one is going to come up in the background, deployed through whatever mechanism it is that you deploy these things. So, and then we've deregistered him from the load balancer, so he won't get any more traffic. And you can do that one of two ways. You can do that like flip of a switch, he gets no more traffic. Or you can say, you know what, drain the queue. Let him finish whoever he's talking to, but no new connections. So you can do it a couple different ways. Now, not only do we not want him serving customer traffic, we don't want anybody talking to this thing. We don't know what's up with it yet. We haven't done our investigation. So we'll slap down a security group that says, you know what, no traffic in or out. 0 packets in, 0 packets out. And again, it's a couple of EC2 commands, modify instance attribute, blah, 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 and, put the security group on it. Don't let it terminate. We don't want this thing to die. We don't want it to go away. It might have running programs in memory that we're interested in getting. It might have log files and tools on it that we are interested in getting. So we need to get the resources off of this guy. So we try to stop it from killing itself. And we try to stop anybody who comes along and says, ooh, that guy's in trouble. I'll terminate it. This will actually make administrators unable to terminate it without going through some extra steps. Cool, so we've isolated him. He's not talking to anybody, and he can't talk to anybody, and he's been tagged. And so now I want a copy of the hard drive. I want to know what was on that hard disk. And so we have this thing called EBS, Elastic Block Store. This is the hard drive of that instance, right? It's a SAN that we provide, and you can have virtual hard drives. You take snapshots of them. All right, so we're going to take a snapshot of that volume, and that snapshot is block for block, byte for byte, whatever that thing thinks is on its hard drive. If you got something clever that was writing in slack space outside the file system, we've got those blocks. If you wrote to that block, we have that block. So we're going to get a complete snapshot, and we're going to roll it off to Amazon S3, which is our robust region-wide storage. It's a funny thing about S3, we say it has 11 nines of durability, right? So 99.9999, 11 nines of durability. That's the probability that we're going to lose a byte that you put there. And when I was doing my AWS training, they have, they put you through the standard training about all the services and what they do, and they put up a little slide that says S3 has 11 nines of durability. But the voice actress says, Amazon S3 has 99.99999, like actually read all 11 nines. I was like, no, that's not how we say that. But the point is that you now have a snapshot in S3, and that snapshot can't be modified. And if you go lock it down, it can't be deleted, it can't be changed. It is going to be just what it is. And again, it's just a command line. Create snapshot on that volume. And by the way, let's put that tag on there, that reference ID. Remember, we're tagging all the assets related to this incident. We'll be able to go get them later. Cool, so we got this hard drive snapshot. Now, chances are you want to do some forensics on this thing, right? You don't want to log into that instance. You don't want to pollute the instance. But you need to get find out what's going on, right? So we're going to launch EC2 run instance, some forensics instance that we already set up. I don't know, this is like Kali Linux with a bunch of tools on it, some Windows box with some Windows tools, whatever it is. We're going to launch one. We weren't running it before. Why would you run one? You don't want to pay for things to run when you're not using them. But it's sat there ready, so spin up a copy. And again, the great thing about this is that instance will never work on any other case. There's no danger of polluting evidence from one case into another case. You're never going to have this instance talk to anything except for the instance, the hard drive and the data and stuff related to the thing it's investigating right now. She gives you some nice sort of like there's no danger of accidentally getting data from one case showing up in the investigation of another. And then we can basically connect that copy. Remember that copy that we did of the EBS volume? We'll make a new copy and we'll attach it as like a second hard disk on the forensics tools instance. So basically, your C drive, your dev SDA, whatever, that is the forensics tools that you've installed, that you run, and whatever it is. And then dev SDF or the D drive or whatever, that's this copy of the instance that we're investigating. I get a copy. You know what? If you trash it, if you screw something up, you mount it read-write and you change the data and you think, oh crap, that messes up our evidentiary integrity here. That's all right. Go get a fresh copy. You just make as many copies as you like. And then we may want to see the processes that are running. What's in RAM? What is going on in this thing? I might want to log into it, or I might want to do something that connects to the live instance. Remember, I didn't kill it. I didn't terminate it. I just walled it off so it's not going to talk to any people I care about. And so now I could create a security group that says, you know what, authorized security group Ingress, let the forensics tool instance talk to this thing, but nobody else. So now I've actually allowed some ingress, and I've allowed it on every port because we're trying to figure out what's it listening on, what's it trying to do. And I can actually go, now logged into my forensics instance, I can go talk to this guy running. I could install Lime, for instance. Lime is a Linux memory extractor, right? It'll give you a RAM dump of everything in the instance. I could do that over this connection if I want. So that's pretty cool, but it sounds like work. All right, so all those commands, that's like typing and stuff. Come on. So anything, I don't want to do work, right? I'm in my slippers and my pajamas here. You haven't seen the pajama part yet. We've done all this talking about incident response, and I might have been with a shirt and tie sat at a computer. Anything that I can write as a series of commands like that, well, obviously I could bang that out in a bash script or something, right? I don't have to type those. But if I could bang it out in a bash script, I could write that as a Python program that's, Bot03, the AWS API library. So I could write a little Python program that does this stuff. And if I can make it a Python program, I can turn that into a Lambda function. And you may not know what Lambda is. Lambda is one of our services that's kind of like code as a service. You copy paste some Python into a web browser input field, and we run it. If you use Heroku, similar kind of thing, right? We just run the code that you give us. We spin up however many Linux instances you need for whatever traffic you're getting. We tell you what environment that's going to run, which Python runtime, which Linux runtime, and so on. There's no persistent storage. There's no, if it wants to persist some data, it better write that, make a database connection, or put an S3 object somewhere, because it, as a function, doesn't get anything. And then we charge you per 100 milliseconds. Per 100 milliseconds of execution time. Nobody calling it, nobody paying nothing, right? But if you call it, you pay by the hundreds of milliseconds. So that's a great thing. So now I can just make that Python program into a Lambda function. But if I can make it a Lambda function, then I could trigger it automatically in response to CloudWatch events, right? So I've got my incident response, I'm in my pajamas, and I'm fast asleep. So this is what incident response in the cloud looks like. Incident response in the cloud is when you come into work and oh, by the way, there was a thing last night. We tagged it. We put all the stuff away. We spun up your forensics tool instance. Here's the IP. Why don't you log in and have a look? That's the kind of thing that you can do when your environment participates in its own management, when your environment actually collaborates with you to automate security. Now, again, this still sounds like work, right? I would have to go write that. I don't want to write that. So I didn't. I don't have to. There's, in fact, where is my Firefox? So there is, in fact, this threatresponse.cloud. If you don't know these guys, this is definitely somebody to go take a look at, threatresponse.cloud. Sponsored, by the way, not just us. Some Mozilla and some Microsoft people are participating as well. And they must do DevOps, because look at that beard. They have 3 really cool tools. They've got AWS IR, which I'll show you in a second. It was an incident response thing. So all that stuff I said you could write, you don't even have to write. They already wrote it. It's on GitHub. Incident Pony, which is trying to do sort of orchestration, right? Because once you've got incidents, Well, now you got to go orchestrate the incident. Where's the S3 bucket, the EC2 instance, the network logs? You need to gather all those things together. And Margarita Shotgun, I love when tools have a really good story for why they're called what they're called. Remember Lime, the Linux memory extractor, right? Lime is this kernel module that lets you pull the RAM out of a Linux instance. So you get this nice RAM dump and you go see what was running. Well, if you had to like blast the Lime kernel module into thousands of instances across your EC2 estate, it's kind of a Margarita Shotgun. There, we got all these instances full of this kernel module now. So this is really cool. And in fact, we can even look at what does it look like when you isolate an instance, right? So this is just the output of, and this is right off the AWS IR GitHub. Oh, we got old men in the room, like me. There you go. Big mode. Yeah, so if you actually wanted to do incident response using AWS IR, right, you have AWS IR. By the way, my forensics instance is going to come from this CIDR range, so go ahead and allow that. And here's my target, here's the IP address, go. Right, well, the first thing, like, where might that be running? There's 16 regions in the world. Is it in Korea? Is it in Australia? Is it in Canada? Where is this thing? And so it searches, it finds it, and then you can see down here at the bottom, now let's go do something about it. So now, okay, we found it. Let's isolate the host. That's that whole security group thing, not talking to anybody anymore. Tag it. Snapshot it, figure out where the examiner, so the forensics instance, where's that guy going to be? And now, let's start getting RAM. And you can get this sense of what happens. So here's at 2111, we start Margarita Shotgun, and at 2141, we're done. So it took about 20 minutes to dump RAM on that particular instance. And so now, process complete, it's over here in this S3 bucket, there's all your assets. So when you come in, you get your cup of coffee, you're like, oh, there was an incident overnight. Let's go look in this bucket and see what we captured. Anybody want to do something really clever? A lot of times I've seen people here work with honeypots. Like, you should just nail these two things together, right? Honeypot that just has this, so it's just like automatically, trap and keep and deal with it later. So that's incident response in the infrastructure domain, right? Robots do the work for us. We don't do it ourselves. And that is the key to cloud scale security. You can't scale to cloud level, planetary level, if you have humans do all the work. The humans keep moving up the value chain. I had a chance to talk to our CISO, Steve Schmidt, brilliant guy, runs security for the cloud. And I said, look, Steve, we must have so many incidents, so many alerts. Remember, heck, we also have this friendly policy of go ahead, file a SEF2 ticket, we'll sort it out. Like, this must be a real problem with alert fatigue, right? Alert fatigue is a real thing where people, you keep seeing that dialog box that says, Java's about to delete all your files, is that okay? Yes. Oh, crap. Alert fatigue is a real thing. And I said, Steve, we must have a real issue with alert fatigue. Like, what do we do to defend against that? And his answer was automation. And anything that we see a lot of, we write a function to deal with it. Like, if I'm seeing the same stupid alert every morning at 9 a.m. because some stupid job does this one stupid thing, and I say, let's make sure that we're recognizing just the one stupid thing and we're resolving it. So if there is an unusual thing that's not just the usual stupid 9 a.m. alert, I'm still going to see that. And the whole purpose is anything that's happening a lot, either you make it stop happening or you automate the alerting. So the only things that bubble up to humans are unique, they're new, they're the kind of thing only a human can really decide. And that's how we avoid alert fatigue. If you've got some incident response thing that's just filling you full of stuff, you're going to have alert fatigue. And people are going to miss important issues because they're just used to clicking OK a lot. So the service domain thing is actually a lot shorter and it's a lot smaller. There are a handful of things that are really important that you have to deal with. And S3 bucket policies, changes in IAM permissions, credential exposure, these are the usual biggies. And the answer on that one is, again, AWS IR, they do a really great job on this whole key compromise piece. You say, here's our key that got compromised. Go get it. And so, all right, we know what we're doing. We'll disable the key. We're going to revoke any tokens that were issued to that key. And we're going to gather some logs. And we're going to dump it all in our Cloud Response bucket. So that's also really cool. There are some other incidents that you might have to deal with, but a lot of that's just automated for you. And so the last couple things I do want to talk about quickly is, how some customers do it. Obviously, you guys are familiar with the usual customers like Netflix, but we've got others, right? And so like Alfresco, these guys created a thing called Prowler, which is also worth knowing about. Prowler will rip through your AWS account looking for violations of the CIS, Cloud Infrastructure Security benchmarks for AWS. And so it'll look for security violations, and it'll go all across your account and look for interesting things. This is really kind of basics. This is kind of 101. Like, eventually this thing should start to report nothing, and you still have work to do. But like, if this thing turns up anything, well, you got work to do. And then Mozilla, obviously, they created the threat response thing, and they contribute to a lot of this stuff. Really important to realize there's a whole ecosystem of people who contribute. So there you go. I mean, the bottom line is, you can respond to incidents. You can do it automatically using software. You can sit in your pajamas and have coffee and let the robots do the hard work, right? Awesome. Thank you very much. I'm happy to take questions by email, or hit me up at the pub tonight or whatever. Thank you.